Hello everyone, this is Prashant. Today let us see some exercise problems on continuity. So before going to the examples, you need to remember these things. Already I had given the proofs of all these results in the previous videos. That is, every constant function is continuous, every identity function is continuous, every polynomial function is continuous, every rational function is continuous, modulus function f of x is equal to modulus of x is a continuous function, and this we have seen in the form of first theorem. The sum, difference, product and quotient of two continuous functions is also continuous. If f is continuous, this implies negative of f is also continuous. And finally we have, if f is continuous, then in reciprocal of f, that is 1 by f, is also continuous. So e points na ನೀವು ನೆನಪಿಟ್ರೆ directly, if you have a constant function, you can write it as since every constant function is continuous, this function is continuous. So ಈ results ಅನ್ನು ನೆನಪಿಟ್ಟುಕೊಂಡ್ರೆ you can directly write the continuity of the certain functions which are given in the examples. So in addition to this, you need to remember, even this I had explained in the previous video, that when you need to go for LHL and RHL, when and when not to. So suppose if you have a function f of x is equal to 4x ax plus b x square, that is single function idaga you need not go for LHL and RHL. But if you have a branched function, that is f of x is equal to 2x when x is less than or equal to 0, and f of x is 3 when x is greater than 0. So inta case olagade, that is when the function is branched function, you need to go for LHL and RHL. With addition to this, ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ, here x is less than or equal to 0, here x is greater than 0. Whenever the sign is inequality, that is less than, greater than, here you may arise the cases as by taking the constant c less than 0 first case, c is equal to 0 second case, and c greater than 0 to be third case. So c less than 0 first case ಇದ್ದಾಗ ಅಲ್ಲೂ LHL and RHL ಬೇಕಾಗಿಲ್ಲ, c greater than 0 ಇದ್ದಾಗ LHL and RHL ಬೇಕಾಗಿಲ್ಲ. But whenever you are taking equality sign, you need to go for LHL and RHL. So branched function ಒಳಗಡೆ wherever you have equality sign, that is partition ಎಲ್ಲೆಲ್ಲಿ ಬರ್ತದಲ್ಲ, at those points you need to go for LHL and RHL. So let us see the first example. This is very first example of the exercise. Prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and x is equal to 5. So e function ನೋಡ್ಕೊಂಡ್ರೆ f of x is equal to 5x minus 3, it is just a single function. So in this case you need not go for LHL and RHL, just to limit calculate ಮಾಡ್ರಿ and value of the function at the given point. So the given function is f of x is 5x minus 3 and the points are 3. ಇಲ್ಲಿ ಕೊಟ್ಟಿರುವಂಥ 3 ಪಾಯಿಂಟ್ಸ್ ಅದಾವೆ. x is equal to 0 1 point, x is equal to minus 3 second point, and x is equal to 5 is the third point. So you can solve this by taking one point at a time. First let us see for x is equal to 0. So ಕೊಟ್ಟಿರುವಂಥ function f of x is equal to 5x minus 3 at x is equal to 0. So let us calculate the continuity of this function at x is equal to 0. So at x is equal to 0, limit of the function f of x as x tends to 0 ಎಷ್ಟಾಗ್ತದ್ರಿ, limit f of x the value is to 5x minus 3. So in place of f of x I am substituting 5x minus 3 as x tends to 0. So evaluating this limit, you get 5 into 0 minus 3, that is 0 minus 3, that is minus 3. And value of the function at 0, f of 0 is equal to 5 into 0 minus 3, that is also minus 3. Here you can see that the limit of f of x as x tends to 0 and f of 0 both are having same values, minus 3, both are equal. Hence we say that the function is continuous at x is equal to 0. So in the same fashion you can calculate for the point x is equal to minus 3. So again we consider the limit of f of x as x tends to minus 3. Here the function is same, 5x minus 3, limit of 5x minus 3 as x tends to minus 3. So this gives you 5 into minus 3 minus 3. So this will be minus 15 minus 3, that will be minus 18. And value of the function at minus 3, f of minus 3 will be minus 18 as well. So in this case also, limit of f of x as x tends to minus 3 is equal to f of minus 3. Hence the function is continuous at x is equal to minus 3. In the same fashion you can check out for x is equal to 5 case. So second example you can try, it is just similar to the first example what I had explained you. So let us go for third example. Examine the following functions for continuity. So here the first function is f of x is equal to x minus 5. So ಇಲ್ಲಿ observe ಮಾಡ್ರಿ, here they have given to verify the continuity of this function. At what point? The point has not been mentioned here. ಇಲ್ಲಿ particular point ಕೊಟ್ಟಿಲ್ಲ. So ಇಂಥ function ಒಳಗಡೆ you need to consider general point C. As we had solved in the worked examples, you need to consider here also the general point C. So f of x is equal to x minus 5. So this function is defined for all the real numbers. ಎಲ್ಲೂ ಕೂಡ ಇನ್ಫಿನಿಟಿ ಆಗುವಂಥ ಚಾನ್ಸ್ ಇಲ್ಲ. ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದ c to be any real number. Let c be any real number. So the limit of the function f of x as x tends to c will be limit of f of x na value x minus 5 as x tends to c. This will be c minus 5. And value of the function at c, f of c will be c minus 5. Just you need to substitute c in place of x. So here also you can see that the limit of the function f of x as x tends to c is same as f of c. Hence f is continuous at this point, particular point, at this point c. So since we have taken c to be any arbitrary real number, we can conclude that this f is continuous at every real number. So second example, f of x is equal to 1 over x minus 5, where x is not equal to 5. So I had told you that ಯಾವುದೇ ಒಂದು ಫಂಕ್ಷನ್ ಇಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರಲ್ಲ ಅದ್ರ ಪಕ್ಕಕ್ಕೆ ಕೊಟ್ಟಿರೋದು ವಾಟ್ ಇಸ್ ದಿಸ್ ಇಸ್ implies the domain. Actually the domain x is not equal to 5 ಅಂತಂದ್ರೆ this function has the domain all the real points except x is equal to 5. x is equal to 5 ಅನ್ನೋ ಪಾಯಿಂಟ್ ಅನ್ನು ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೋ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನು ಕೊಟ್ಟರು ಕೂಡ ಈ ಫಂಕ್ಷನ್ ಡಿಫೈನ್ ಆಗ್ತದೆ. ಸಪೋಸ್ ಇಫ್ ಯು ಗಿವ್ x is equal to 5, ಎಷ್ಟಾಗ್ತದೆ ರೀ? f of 5 is equal to 1 over 5 minus 5. 1 divided by 5 minus 5. 5 minus 5 will be 0. 1 divided by 0 will go to infinity. ಹೌದಾ? ಸೊ ದಿಸ್ ಫಂಕ್ಷನ್ ವಿಲ್ ನಾಟ್ ಬಿ ಡಿಫೈನ್ಡ್ at x is equal to 5. Therefore this function is defined for all the real numbers except x is equal to 5. So here also you need to consider a general point c to be any real number which is not equal to 5. So that's why I have mentioned here, let c be any real number which is not equal to 5. Other than 5 you can give any real number. ಸೊ ಇಂಥ ಪಾಯಿಂಟ್ ಒಳಗಡೆ, ಇಂಥ ಸಿ ಅನ್ನೋ ಪಾಯಿಂಟ್ ಒಳಗಡೆ ನಾವು ಲಿಮಿಟ್ ಕಂಡುಹಿಡ್ಕೊಳ್ಳೋಣ. ಲಿಮಿಟ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಆಸ್ ಎಕ್ಸ್ ಟೆಂಡ್ಸ್ ಟು ಸಿ ವಿಲ್ ಬಿ ಲಿಮಿಟ್ 1 divided by x minus 5 as x tends to c. Just in place of x you substitute c, you will get 1 over c minus 5. And also the value of the function at c is equal to 1 over c minus 5. So here also limit of f of x as x tends to c is equal to f of c. Hence f is continuous at c. Since c being an arbitrary point, we conclude that f is continuous at every real number. These are very simple examples, guys. So the third case, f of x is equal to x square minus 25 divided by x plus 5, where x is not equal to minus 5. So minus 5 ಕೊಟ್ಟರೆ ಏನಾಗ್ತದೆ? minus 5 square, 25 minus 25, 0 divided by 0 by 0, indeterminate form. So function will not be defined. So that's why you can give here the value to be any real number except x is equal to minus 5. So here also I consider c to be any real number which is not equal to minus 5. So ಇಲ್ಲಿ limit f of x as x tends to c ಎಷ್ಟು ಬರ್ತದೆ? Limit f of x ನ value x square minus 25 divided by x plus 5 as x tends to c. ಸೊ ಈ ಲಿಮಿಟ್ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ಎಲ್ಲೆಲ್ಲಿ ಎಕ್ಸ್ ಇದೆ ಅಲ್ಲೆಲ್ಲಿ ಸಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿರಿ, ಯು ಗೆಟ್ ಸಿ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ 25 ಡಿವೈಡೆಡ್ ಬೈ ಸಿ ಪ್ಲಸ್ 5. ದಿಸ್ ಕುಡ್ ಬಿ ಸಿಂಪ್ಲಿಫೈಡ್ ಆಸ್ ಸಿ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ 5 ಸ್ಕ್ವೇರ್ ಡಿವೈಡ್ ಬೈ ಸಿ ಪ್ಲಸ್ 5. ದಿಸ್ ಇಸ್ ಆಫ್ ದ ಫಾರ್ಮ್ ಎ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಬಿ ಸ್ಕ್ವೇರ್. ಎ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಬಿ ಸ್ಕ್ವೇರ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಂತಂದರೆ ಯು ಕ್ಯಾನ್ ಸಿಂಪ್ಲಿಫೈ ಟು ಬಿ ಎ ಪ್ಲಸ್ ಬಿ ಇಂಟು ಎ ಮೈನಸ್ ಬಿ, ಎ ಪ್ಲಸ್ ಬಿ ಇಂಟು a minus b, that is c plus 5 into c minus 5 divided by c minus 5. Here both these terms c plus 5 get cancels and you are left out with c minus 5. You can just simplify this, not a problem, not an issue, okay? And the value of the function at c, f of c, will be just in place of this function f of x, you can substitute c in place of x, that is c square minus 25 divided by c plus 5. After simplification again you will be getting c minus 5. Here limit of f of x as x tends to c is same as f of c. Hence we conclude that the function f is continuous at every real number c which is not equal to minus 5. So this is very interesting example. F of x is equal to modulus of x minus 5. Modulus of x minus 5. So in the previous videos I had shown you, I had given the proof for modulus function. That the modulus function is continuous. So here you can directly use those results and give the proof of this continuity of this function. So here the given function f of x is modulus of x minus 5. This is a modulus function and is defined for every real number. Ellu kuda infinity aguanta chance illa. Therefore this modulus function is defined for all the real numbers, and we know that every modulus function is continuous. Since every modulus function is continuous, we conclude that this f of x, which is given by modulus of x minus 5, is also continuous function. ಸೊ ಅದಕ್ಕೆ ಹೇಳಿದ್ದು ನಾ ಮುಂಚೆನೇ ಈ ವಿಡಿಯೋ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ನಾ ಪಾಯಿಂಟ್ಸ್ ಹೇಳಿದ್ದಲ್ಲ, ದೋಸ್ ಪಾಯಿಂಟ್ಸ್ ಆ ಪಾಯಿಂಟ್ಸನ್ನು ನೆನಪಲ್ಲಿ ಇಟ್ಟರೆ ಸೊ ಇಂಥ ಫಂಕ್ಷನ್ಸ್ ಬಂದಾಗ ಯು ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ಕನ್ಕ್ಲೂಡ್ ಬೈ ಯೂಸಿಂಗ್ ದೋಸ್ ರಿಸಲ್ಟ್ಸ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್, ಈಸ್ ದ ಫಂಕ್ಷನ್ ಎಫ್ ಡಿಫೈನ್ಡ್ ಬೈ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಇಫ್ ಎಕ್ಸ್ ಇಸ್ ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1 ಆ್ಯಂಡ್ 5 ಇಫ್ ಎಕ್ಸ್ ಇಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1 ಈಸ್ ಕಂಟಿನ್ಯೂಸ್ at x is equal to 0, at x is equal to 1, at x is equal to 2. Here they have given you 3 points: at x is equal to 0, at x is equal to 1, at x is equal to 2. So ಇಲ್ಲಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರೋ ಪ್ರಕಾರ this function is branched. So ನಿಮ್ಗೊಂದು ಲಕ್ಷ್ಯ ಬರ್ತದೆ that I need to go for LHL and RHL. ಯಾವಾಗ ಹೋಗ್ಬೇಕು LHL and RHL? Whenever you are having equal to sign. ಇಲ್ಲಿ less than 1 ಐತಿ, don't go for LHL and RHL. Greater than 1, don't go for LHL and RHL. Equal to 1, equal to 1. So at x is equal to 1. Here also you have equal to 1. Here you are having at x is equal to 1. So at x is equal to 1 bandaga, you need to go for LHL and RHL. Let us see the solution. So first case, at x is equal to 0. At x is equal to 0. X is equal to 0 ಏನು ಬರ್ತದ್ರಿ? First branch second branch? First branch. At x is equal to 0, less than 1, less than 1 ಅಂದರೆ x is equal to 0 ಇಲ್ಲೆಲ್ಲೋ ಬರ್ತದೆ. ಸೊ ಈ ಕೇಸ್ ಒಳಗಡೆ the function value is x, f of x is equal to x. So at x is equal to 0, limit of f of x as x tends to 0 will be limit of f of x na value x as x tends to 0, which will be 0, and f of 0 will also be 0. Thus f of x is equal to limit of f of x as x tends to 0 is equal to f of 0. Hence we conclude that the function is continuous at x is equal to 0. ಇಲ್ಲಿ ಗಮನ ಇಟ್ಕೊಳ್ಳಿ. So here I am having the function f of x is equal to x. You can show the continuity of this function by following these steps. ಈಗ ಸದ್ಯಕ್ಕೆ ಏನು ಹೇಳಿದಲ್ಲ ಆ ಸ್ಟೆಪ್ಸ್ ಅನ್ನು ಫಾಲೋ ಮಾಡಿಕೊಂಡು ನೀವು ಕಂಟಿನ್ಯೂಟಿಯನ್ನು ಹೇಳ್ಬೋದು. ಅಥವಾ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಫಂಕ್ಷನ್ f of x is equal to x. ಎಂಥ ಫಂಕ್ಷನ್ ರೀ ಇದು? f of x is equal to x. ಇನ್ಪುಟ್ x ಕೊಟ್ಟರೆ ಔಟ್ಪುಟ್ x, ಇನ್ಪುಟ್ 1 ಕೊಟ್ಟರೆ ಔಟ್ಪುಟ್ 1, 2 ಕೊಟ್ಟರೆ 2, ಇನ್ಪುಟ್ 10 ಕೊಟ್ಟರೆ ಔಟ್ಪುಟ್ 10. That means input and output are the same identity function, and we have shown that every identity function is continuous. ಆ ರಿಸಲ್ಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಜಸ್ಟ್ 2 ಲೈನ್ಸ್ ಒಳಗಡೆ ನೀವು ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ಕೋಬಹುದು that since every identity function is continuous, here also the function f of x is continuous ಅಂತಾನೂ ಕೂಡ ಬರ್ಕೋಬಹುದು, or else you can go for this way. Second case, at x is equal to 1, is equal to 1. So is equal to 1 case ಇಲ್ಲಿ ಬರ್ಲಿಕ್ಕತ್ತದ. In this case you need to go for LHL and RHL. So LHL ಅಂತಂದ್ರೆ limit of f of x as x tends to 1 minus limit of f of x as x tends to 1 minus 1 minus ಅಂತಂದ್ರೆ less than 1 branch. Less than 1 branch is first branch. In this case you are having f of x to be x. So f of x na x ಅಂತ ಹಾಕೋತೀನಿ. As x tends to 1 ಹಾಕಿದಾಗ you will be having the limit value to be 1. And RHL, limit of f of x as x tends to 1 plus greater than 1 branch. Greater than 1 branch ಯಾವುದು? Second branch, f of x is equal to 5. So f of x is equal to 5. So ಇದನ್ನ ಲಿಮಿಟ್ ಇವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡ್ಕೊಂಡಾಗ ನಮಗೆ ವ್ಯಾಲ್ಯೂ 5 ಬರ್ತದೆ. Since limit of any constant value is the constant itself. So here you can observe that LHL and RHL are not equal. So here itself I can decide that the function is not continuous at x is equal to 1. So the last case is whenever x is equal to 2. X is equal to 2 ಯಾವ ಬ್ರಾಂಚು? ಗ್ರೇಟರ್ ದೆನ್ 1 ಇಲ್ಲೆಲ್ಲೋ ಬರ್ತದೆ 2, ರೈಟ್? ಸೊ ಇಂಥ ಕೇಸ್ ಒಳಗಡೆ ದ ಫಂಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 5. ಸೊ ಇಯರ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 5. ಸೊ ಈ ಫಂಕ್ಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 5 ಎಂಥ ಫಂಕ್ಷನ್ನು? ಇನ್ಪುಟ್ 1 ಕೊಡ್ರಿ, ಔಟ್ಪುಟ್ ಎಷ್ಟು? 5. ಇನ್ಪುಟ್ 2 ಕೊಡ್ರಿ, ಔಟ್ಪುಟ್ ಎಷ್ಟು? 5. ಇನ್ಪುಟ್ 100 ಕೊಡ್ರಿ, ಔಟ್ಪುಟ್ ಎಷ್ಟು? 5. ದಟ್ ಮೀನ್ಸ್ ಇನ್ಪುಟ್ ಏನಾದರೂ ಕೊಡ್ರಿ ಔಟ್ಪುಟ್ ಇಸ್ ಆಲ್ವೇಸ್ 5. ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ಫಂಕ್ಷನ್. This function is constant function. So since we have shown that every constant function is continuous, here I can conclude that this function f of x is equal to 5 is also continuous. Since f of x is equal to 5 is a constant function and every constant function is continuous, I can conclude that this function f of x is continuous at x is equal to 2. So our previous results ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಕಂಟಿನ್ಯೂಟಿ ಈಸಿಲಿ ಶೋ ಮಾಡ್ಬೋದು. ಓಕೆ, Next example. Find all the points of discontinuity of the following functions. So as in the previous cases, you can go for by taking the arbitrary point C and go with the cases. So given function f of x is equal to 2x plus 3 when x is less than or equal to 2 and 2x minus 3 when x is greater than 2. So ಇಲ್ಲಿ 3 cases ಬರ್ತಾವೆ. X if you consider C to be any real number, C less than 2 one case, C is equal to 2 second case and C greater than 2 third case. So less than ಇದ್ದಾಗ no need to go for LHL and RHL. Greater than ಇದ್ದಾಗ no need to go for LHL and RHL. Is equal to 2 ಇದ್ದಾಗ you have to go for LHL and RHL. Let us see the solution. So case 1, when C is less than 2, C is less than 2 branch ಯಾವುದು? Less than 2 branch is first. So here the function value is f of x is equal to 2x plus 3. f of x is equal to 2x plus 3. ಈ 2x plus 3 ಅನ್ನೋದು ಎಂಥ ಫಂಕ್ಷನು? Polynomial function, and already we have shown the continuity of the polynomial function, that is every polynomial function is continuous anta already ತೋರಿಸ್ಕೊಂಡಿದ್ದೀವಿ. So using that result I can conclude that this function f of x is equal to 2x plus 3 being a polynomial function is also continuous. Therefore f of x is equal to 2x plus 3 is continuous for all c less than 2. So now point c less than 2 consider ಮಾಡಿದೆನಲ್ಲ, so at all these points the function f of x is continuous. Second case, when c is equal to 2, c is equal to 2 ಇದ್ದಾಗ you need to go for LHL and RHL. LHL is limit of f of x as x tends to 2 minus. So limit of f of x as x tends to 2 minus ಅಂತಂದ್ರೆ less than 2 branch. Less than 2 branch is first branch 2x plus 3. So here the function value f of x will be 2x plus 3. So ಈ ಲಿಮಿಟ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ you get 2 into 2 plus 3. 2 2s are 4 plus 3, that will be 7. And RHL, limit of f of x as x tends to 2 plus greater than 2 branch. Greater than 2 branch is 2x minus 3. So here I substitute f of x to be 2x minus 3. So ಈ ಲಿಮಿಟ್ ಅನ್ನು ವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಿದಾಗ I get 2 into 2 minus 3, that is 4 minus 3, that is 1. So here you can observe that LHL and RHL are different. They are not equal. Hence I can conclude that the function is not continuous at c is equal to 2. c is equal to 2. So final case, when c is greater than 2, ಇಲ್ಲಿನೂ ಕೂಡ c greater than 2 ಯಾವ branch? Second branch. Again in the second branch the function is 2x minus 3. Again it is a polynomial function. Since every polynomial function is continuous, I can conclude that this function f of x is equal to 2x minus 3 is continuous. This function f of x is equal to 2x minus 3 is continuous. So ಈ ಮೂರು ಕೇಸಸ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಫಸ್ಟ್ ಕೇಸ್ c less than 2 ಫಂಕ್ಷನ್ ಕಂಟಿನ್ಯೂಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಕಂಟಿನ್ಯೂಸ್. ಸೆಕೆಂಡ್ ಕೇಸ್ ಫಂಕ್ಷನ್ ಕಂಟಿನ್ಯೂಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್. ಥರ್ಡ್ ಕೇಸ್ c greater than 2 ಕಂಟಿನ್ಯೂಸ್ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಇಟ್ ಇಸ್ ಕಂಟಿನ್ಯೂಸ್. ಸೊ ಈ ಮೂರು ಕೇಸನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಐ ಗೆಟ್ ದ ಫಂಕ್ಷನ್ ಟು ಬಿ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಓನ್ಲಿ ಇನ್ ದ ಸೆಕೆಂಡ್ ಕೇಸ್. ಈ ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಯು ಹ್ಯಾವ್ ದ ಫಂಕ್ಷನ್ ಟು ಬಿ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್. ಸೊ ಈ ಮೂರು ಕೇಸಸ್ಸನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಐ ಕ್ಯಾನ್ ಕನ್ಕ್ಲೂಡ್ ದ್ಯಾಟ್ the point c is equal to 2 is the only point of discontinuity of the given function. ಅಂದರೆ ಈ ಪಾಯಿಂಟ್ ಏನದಲ್ಲ x is equal to 2 or c is equal to 2, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮಾತ್ರ the function is discontinuous. ಮಿಕ್ಕಿದೆಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಕೂಡ the function is continuous. ಸೊ ಇದೇ ರೀತಿ ನೀವು ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಈ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನ ಟ್ರೈ ಮಾಡ್ಬೋದು 10th 11th and 12th. ಇಲ್ಲಿನೂ ಕೂಡ ಸೇಮ್ you need to consider the cases and go for calculation of LHL and RHL and the 3 cases 10th 11th and 12th. ಈ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ರಿ. In the next video I will be giving you some more examples on this continuity.